Okay.
Looks good.
Should be perfect. So I'll briefly go into the structures groups, just showing the key elements there, and then you can go and see more about it in the reference that we mentioned before. So the structures group is located in the middle of this diagram, and this with data and metadata organization. So as we mentioned before, referential metadata at the top includes things like quality information, methodology, and other elements that qualify in some way data. Referential metadata is organized in structures and attributes, and also other classes, which are not shown here. Data is organized in data sets, as we mentioned before, which consist of data points, and they are further described by data structures and their components. So that's kind of what we are starting from. And next, we are going to see with an example how this works for a particular type of data. So let's look at this data about patients containing some information like the pulse, the temperature, and the weight, together with some additional information about the service that took that measurement and the date that they were taken. So each row is a data record composed of data points. All records together form a data set. So far, so good. That's kind of the usual way of describing rectangular data. Now, each column contains the values of a variable. So a data structure provides additional semantics in the form of data structure components, and each of which describes the role of the associated variable in green, which role it plays in the given data structure. So for instance, the patient variable at the top on the left plays the role of identifier component, which means its values are IDs. So in general, identifier components identify the statistical units in the data. In this case, the units are patients. Heart rate, body temperature, and body weight are all measure components, which contains the observations. So that's kind of the definition of a measure component is basically the values that we are interested in. Service and date are attribute components that provide context for the observations. So in this case, it's the date and who took it, like the service or the place where they were taken. So why do we need this additional layer with the data structure and the components? Can we just use the variables? Well, yes, the variables provide some information, but the role can change from one data structure to another. And that's what the data structure is trying to capture. So it's not enough for some situations. I mean, in other situations, just knowing the variable might be okay. Just taking a look at the data and understanding, for instance, what pulse, temperature, and weight mean. I mean, you don't need anything else other than the variable. But if you want to go deeper into the way the data is organized in the data set, the data structure components give you a different look and other information. So let's say that the data structures provide a different viewpoint to understand and analyze the data. So you can change the data structure without changing the data set and without changing the variables by just looking at the data in a different way. So for instance, consider this other data set. So this data set contains information about the hospitals and their clinics and services, and it's basically counting the number of doctors for them. Just very simple, like an oversimplification, just for the sake of the example. So in this case, one variable from the first data set plays a different role. Service, for instance, if you look at service, the one at the top here, hope you can see my mouse. So it plays a different role now. It was an attribute component before for the patient data set, and it's an identifier component here. It's part of an identifier component. It's not the only one. I mean, you need to also have the hospital. Date, in contrast, plays the same role of attribute component in both, with the only difference that in one case we show the detailed date and the other one just the year. But it's the same variable and the same type of component. So the new variables, hospital and the number of doctors, are essentially identifier component first, the hospital, and measure component, the other one. And essentially, they are playing the same role as the measure component before. So it's basically saying the measure component here is identifying the values that we're interested in, and the rest are identification or attributes. Now, this is a useful way of understanding the hospital's dataset, but you can also view the dataset from another viewpoint, which is the dimensional data structure. So we can say that instead of having these identifier components and attribute component, we can make all of these as dimensions in a multidimensional data structure for, let's say, aggregating, or for looking at the data from different perspectives, taking slices, the usual things that you do with the data cube, for instance, for those familiar with data cubes. So in this case, hospital, service, and date become dimension components, and the whole is a dimensional data set. So summing up, data structures add an extra semantic layer so that we can interpret the data in different ways, or refine the way we interpret the data, and look at the data differently depending on the analysis that we are trying to do, or basically the use case. So with that in mind, let me spend some minutes looking at how GSIM, and in particular the concept and the structures group we've seen so far, can be used to drive GSBPM subprocesses. So essentially, we have the GSBPM model for describing what the business processes in the agencies do and how to put them together. So we have a catalog of information about the different type of activities that we perform in statistical agencies. So it's interesting to note that with the concept and the structures we discussed so far, we can describe most of the inputs and outputs of these subprocesses, together with some exchange and business group classes. But the vast majority are concepts and structures, because the vast majority of the inputs and outputs are data and metadata. And we'll see an example next. So a few years ago, a task team of the supporting standard group looked at different ways of using GSIM and GSBPM together. And these are the things that we were trying to address. So first was to surface the non-obvious relationships between the two models, improving usability and supporting a wider adoption. The models were developed by different communities, so some guidance was needed to iron out, let's say, some wrinkles and fix some misalignment. So that was the first step, trying to make these two work together better. We also wanted to select a robust set of classes that could be used as inputs and outputs of GSBPM subprocesses based on common use cases that take place in many statistical agencies. It turns out that there aren't that many classes needed for that, so that was good. We didn't need to use a big chunk of the GSIM model. It was just a few dozen classes, a couple of dozen classes really, that were involved in pretty much all subprocesses. So in addition, we wanted to help in the design of systems to track information flows through statistical business processes. That's an essential piece of the business analysis that if you don't have the information side of things, you have a hard time connecting essentially the subprocesses in your workflow. And finally, we wanted to make it easier to use those information flows to implement interoperable pipelines and orchestrations with popular implementation standards like DDI and SDMX. So let's see next how that works with an example. So let's consider like a very simple subprocess, well, simple in some sense, but difficult when you look at the methodology. That is captured by a GSIM process step. So process step in GSIM can capture the idea of an edit and imputation subprocess. And is based on some process method, which is a separate class in GSIM. So with those two pieces, you can represent a lot. There are others, again, in the business group that can help define that process step, the logic of the process step better. But those are the essential pieces that you're going to need pretty much in any time that you want to define the process step. So edit and impute uses one or more data sets as inputs together with their data structures and the instance variables. And I mean, represented variables in general when we are talking about the data structures. And produce one or more edited and imputed data sets with their variables as well. So note that the data structure that is being inputted is not in the output because it didn't change. So assuming that in some cases you just output the things that change or the new things, the rest is kept as is. In some other situations or implementations, you might output even the things that didn't change, like the same data structure. But for now, let's assume for simplicity that this is the case here. So then we have this exchange instrument, and the exchange instruments essentially what they are is they are used for sharing the content. So basically, the exchange instrument here is going to have the data sets and the variables and the data structure in some way. So they are going to be associated with the exchange instrument because that's the means by which you got the information in this edit and impute. So note that we don't need exchange instruments between all process steps. Here only is important because the data is coming from a different area, let's say in the agency, and is consolidated in one place for usage downstream. So that's kind of the cutoff decision point that we made, is that if the data, in this particular example, I mean, if this data is going to be shared broadly in the agency and is good quality, then we use an exchange instrument, like say a data hub or data mart. If it's not, if something that is internally developed or is part of the bigger processing area, then it's just sharing more informal ways. We don't go into the details of how that sharing works. So it's important to note that the edit and impute brings the data from the finalized collection step, which in turn brings the data from outside the agency, let's say, or via an exchange instrument, and we get the raw data that is finalized during the collection, is pre-processed in some way, and that is the one that is shared downstream to edit and impute. Now, there is another process that we have downstream, which is review and validate, that is taking the outputs of the edit and impute and the data structure and does the review and validation of them. So making them into data that is shared downstream because it's more usable in more situations and it's better quality than the one that was just received from edit and imputed because it was partially processed. And this includes the exchange instrument, again, because in this case it's necessary, and the data sets and data structural variables that are part of it. And this is then continued downstream and so on and so forth. So the idea here is that by using GSIM, you can connect these process steps into a business process, into a specific way of using GSBPM in your agency or in an area of your agency. So GSBPM as a process can be used in any order, as we hopefully we all know. But when you try to use it, when you start using it in your agency, you need to refine workflows so that the actual implementation can be applied to the business process at hand. So in this case, the pieces that keep this information flow in place are the information classes in GSIM. So the structures and concept group can be very useful for defining these inputs and outputs. And other than the instrument and a few other classes, this is most of what you need in order to create the type of workflow. So this is an important concept that we need to keep in mind when we are trying to work with both models.